IP addressing is very, very important because all the IT systems are assigned with IP addresses, either IPv4 or IPv6. They have to have one of these IP addresses. So IP addresses actually are the means through which all the systems, they communicate with each other. So if you do not understand the IP addressing, you will not be able to understand the entire communication among various systems. Hi, I'm Abdul Vaheed and I'm going to be your trainer in this video. In this video, you are going to learn some IT fundamentals, some information about IP addressing. In IP addressing, you will be learning topics such as subnetting, private IP addresses, public IP addresses, and the importance of Subnet Mask, which actually is fundamentals, but it's going to be very, very useful, and it's important for any discipline. You may be coming from systems background, you may be coming from networking background, or you may be from application background. The knowledge in IP addressing is quite important. Okay guys, happy learning. Please do write your comments if you enjoyed this video. Okay, thank you.
Basically, in this lecture, we start from some basics. So, but we will not be discussing only basics, of course. But my initial discussions, I'll start with some basics so that you guys can have some good understanding of the fundamentals. All right. Okay. So when we talk about networking, the first thing that comes to our mind actually is the topologies. Networking topologies. So these networking topologies, in the past, we used to use this bus topology, also ring topology, and then in the current days, we are using star topology. All right. Basically, bus topology is is connecting the equipment, connecting the equipment, like you will have a backbone cable, all right, which is made of copper. We used to call them as a coaxial cable. Now also these cables are available in the industry, in the market outside, because we still use it for the CCTV networking at home, our offices, our companies. So basically what happens, there will be a coaxial copper cable which actually we will connect some computers like this. I mean, these are the wires again, and to these wires we connect some end devices. I mean, basically we used to connect the computers those days, but these days we are not using this kind of networking anymore. Meaning, bus topology we don't use for IT networking, but we still use. People are still using it for the for the CCTV connectivity at home. So in this here, you can see that this is actually a copper coaxial cable. This and this. These both are copper coaxial cables. Okay. Same thing out here. And then these PCs, with the help of these cables, are joined to the backbone cable with the help of some, we call them as the T connectors. So you will have some sort of T connectors here like this. So these connectors will join them. Okay. Basically, we need to just twist them. Okay. Twist and join them. So something like this. So they look like in a T shape. So that's why we call them as a T connectors. That's all. There is no other reason. So these are the T connectors. And then they are actually terminated at the edges like this. We call them as the terminators. Okay. So this is a terminator. Yeah. So everything has a purpose actually. First of all, the T connector is joining this wire to the backbone cable. That's the purpose of a T connector. Okay. And this is, let's say this is a PC or computer or whatever you're connecting to the network. Of course, the PCs will have a network interface cards. Okay, that one we all know. And this is a coaxial cable. Okay. And this is also a coaxial cable. Okay. And the terminators actually, what they're doing is when machines communicate with each other, PC and communicate to this PC, for example, the signals actually they come from here. And let's say if they're going this way, normally they're supposed to go this way. But what happens when a signal is sent from the PC? It's actually sent as a broadcast. You need to understand these three terms here. Number one is unicast. Number 2 is a broadcast. And the last one is a multicast. Unicast means one to one, meaning one machine sending to other machine is a unicast. Broadcast means one to all, meaning let's say there is some people sitting in my class. When I say something, all of them can hear. That is broadcast. It's like I'm talking to all of you now. That is a broadcast. Now, multicast means many to many, meaning like this one is a from one to many. Actually, groups, for example, if this is sending like this is a source sending to groups of receivers like this. This is a source, actually is going to this group, sending to groups. Let's say the source is Astro, for example. Astro want to send ESPN channel, the sports channel, only to, let's say this is group A, B and C. ESPN will be sent only to group C. It can send the ESPN traffic only to group C. That is possible with the help of multicast. But here, if Astro do broadcast of the ESPN, it will go to all the groups. But that way Astro cannot make money, right? So in order for them to make money, they have to sell the channels. So that's what they have to do this kind of things. So multicast is a technology using which you can send the traffic to groups of receivers instead of sending to everyone. You send to everyone, it becomes a broadcast. So that's the difference between these three types of communication: unicast, broadcast and multicast. Unicast is sending from one to one. If this machine is sending from one to one, it is a unicast. If this machine is sending traffic from one to all, meaning all of them, it is a broadcast. But this machine want to send, for example, to only two of them, it becomes a kind of multicast, meaning there's a controlled broadcast. Controlled broadcast is a multicast. Okay, so that's the difference between these three terms. So now machines actually the first time conversation, for example, when this PC here, with this PC, for example, PC A, B, C, PC A would like to send traffic to PC B. Okay, what normally happens is the first time is going to be a broadcast, because PCA has no idea about who is B and who is C. Okay, so PCA will send a broadcast to find out. So when the traffic comes to the wire here, it will hit the wire here and it will be sent to all the directions of the wire. It goes this direction, it goes this direction. There are only two directions, right? It will go to both the directions. So the traffic coming from here, it will go this direction, also this will go direction. This is how the frequency, this is how the signals flow. It will go this direction here, it will go one copy here, will copy here. So the one going here, it will reach to this PCB. The one going here, it will reach to PCC. But what about the copy going here? It will be absorbed by this terminator. If you don't have a terminator, there is a possibility if you have something else, it will bounce back here again. Something like a wave, it will hit the wall and go back again. So in order not to happen that the bounce back, the terminator will absorb it and kill the signal. That's how it should be. Okay, that's the purpose of a terminator. So now signals actually, when they come here, they go to the PCs and the B, will reply back. So the traffic coming from A to B is actually broadcast. When B replying back, the traffic going back to A only, right? Because A want to talk to B, for example. A want to talk to B, not to C. But A doesn't know who is B. So it will ask who is B. So that who is B is a broadcast. That who is B, the question from A to all of them. Hello, I want to go to B. But it should go to everybody. Everybody listen and only B respond. So A is sending a broadcast. But what B has to do, B don't have to tell everybody that I am B, right? We just have to tell A that, oh yeah, you're trying to reach me, I am B. So what B has to do is the unicast. Okay, so these things only to make you understand what is the difference between unicast and the broadcast, not multicast. Multicast is a different story. We don't need to understand multicast at the moment in detail. Okay, so the bus topology, basically what happens is it uses something called as a media access method. Media access method. This media access method actually used by the machines here. Why? What is the reason? What is the purpose of media access method? Now, okay, we have 3 machines here. Now, these 3 machines actually want to send their signals. But there is a rule here in the networking that at any point of time, this wire, coaxial cable, the copper coaxial cable wire, can only carry signal only, if it is coming from here, from this machine, that means there is already a signal on the wire. If there is already a signal in the wire, if this machine tried to send, it is not going to work, because it is going to collide with the signal. They create a collision. Collision means accident of signals. That is not good. So in order for that not to happen, normally what happens, these machines actually, they have a media access method, meaning when the machines want to put their signal on the wire, they first check the wire, the backbone cable is available or not. They check the backbone cable is available or not. So that is what is the purpose of media access method. The media access method used by this bus topology is called as a CSMA CD, meaning carrier sense multi-access, with collision detection. Carrier sense multi-access with a collision detection, meaning carrier sense multi-access with collision detection. Okay, this actually is called as a media access method used by bus topology networks. So what happens actually when the machines actually trying to put the signal on the wire, and this media access method helps the PC to tell the PC machine that whether there is a signal already on the wire or there is no signal. If there is a signal already, the machine have to wait for some more time. It cannot send. If there is no signal, this machine can put the signal on the wire. All right. But there is always a possibility that 2 machines try to send their traffic at the same time, this machine and this machine. Then what happens? This media access method thinks that there is no signal, and it will put this signal also, it will put this signal also. So the signals are coming this way, they collide. This happens only when 2 machines think that there is no signal on the wire, and they put their signal on the wire, and the signals coming from this way and this way, they collide. That creates actually a collision, right? A collision, which actually is not good. It's an accident of signals. Okay, so basically, unfortunately, in bus topology, there is no avoidance of the collision. There is only detection of the collision. So when the collision is detected, the machines actually will inform the protocol here, which is actually the Ethernet. Ethernet actually is the protocol here. This is in OSLAS, you learn OSLAS, right? In OSLAS, Ethernet is a layer 2 protocol. If you remember the layer OSLAS, right? Layer 2 is actually a data link layer. Ethernet actually is a defined data link layer. That's why we call it as a layer 2 protocol. So the Ethernet actually protocol, when there is a collision, it will send a message to all the other machines to hold on, don't do any further transmission. It is something like, like when there is a accident on the highways outside, what happens? All machines slow down. All the cars are slowed down. Why? Because it is good to slow down because there is an accident. Then again, slowly, the cars in the accident will be moved to the side, and the police will make the traffic go back normal. Something like that. This is a transmission of our signals, okay? So you need to assume that something like that is happening here. So guys, this is the bus topology networks, but we don't use bus topology networks in the IT anymore. Okay, so to address the problems of these collisions and all, the next they came up with the ring topology. So basically what happens in the ring topology is, the ring topology addressed some issues but created some other issues. Let me discuss about it. Okay, the ring topology networks actually they you can visualize they look something like this. Okay, so say for example, you have machines here. Okay, they're connected to a dicey chain of a ring. Okay, and then there will be a piece of software which is actually called as a token. It's actually called as a token. Okay, this token will be going in the ring like this. It will be revolving in the ring. That's why the media access method in the ring topology is called as a token access. The media access method for the bus topology was a CCNA CD. The media access method for the the ring topology is a token access, because based on the tokens they're accessing each other. So the idea here is whoever holding the token only can transmit. That is the media access method. Others only can receive. So once this machine is done sending, then again the token will come back. Maybe this machine can take it. Then this machine only can transmit. So basically here there is no collision. But as I said, this topology also introduced some new issues, like how long this machine have to wait until this machine, maybe this machine is sending, maybe 1 terabyte data. So it will take a long time. So these machines, until that time, these machines have no network access. So they will fail. These machines want to do some network activity. They want to connect to some other servers. They cannot, because they have no network access. So unfortunately, ring topology also was not so successful. And like new technologies came into picture. Part of it was the star topology. So star topology actually is a topology we still currently using in our IT. We are still using star topology in IT. Star topology actually started with a hub as a central device. Hub as a central device, and we connected all these PCs, all servers or whatever. We connected them to the hub, something like this. So basically this one is a hub. So these are all the PCs. So it looks something like, a star. They call it as a star topology, because the formation of topology actually is nothing but the physical appearance of a network. That's called as a topology. Physically how it looks like. We have logical topologies, we have physical topologies. Physical topology, the star name come from the appearance of a network, the physical appearance. Logical appearance, it can be totally different. Let us not talk about logical appearances. We just look at the physical appearance. So guys, star topology actually, when star topology came into the picture, I think it came during 1989, something like this. The hub was a central device. So we use connectors here. These connectors we call them as a RJ45. Until now we are still using it in the wired networking. Both sides will have RJ45 registered jack. RJ means, and we connected the PCs with the help of this RJ45 connectors connected to the cables. This cable actually we call as a twisted pair cable, and hub. That's all. Network. This is the network interface card, NIC. All right. So network interface card is connected to the connector here. Connector connected to the cable. Cable comes to the hub here. Hub has another. This side is another RJ45 connector connecting to the hub. So like this, all the machines are connected to each other with the help of hub. When this machine is sending some traffic, for example, to this machine through the hub, this machine actually has no idea that there is a hub here. Hub actually is a transparent. None of the machines here, they know that there is something called as a hub. Hub actually is at OSI layers. Hub is at a layer 7, which is a physical layer. Layer 1. Layer 1 is a physical layer. The devices at physical layer, they have no intelligence. They are like cables, like a hub, repeaters, connectors. These are the kind of equipment actually defined at physical layer, meaning they have no intelligence, like switches, network interface cards. Okay, these kind of hardware defined at a data link layer 2. So you need to, that's why I said OSI is a very important concept for those who are not from IT background. They have to understand these kind of concepts very well. Then you become more knowledgeable and you can start grasping the networking topics and systems topics. Networking topics, systems topics, these two actually go hand in hand. They complement each other. And then these are the things you have to know in order to work on the cloud. That is the reason I'm covering these two topics. So try to get as much as possible with this. Okay, guys. Well, this is about topologies. Okay. The media access method for the star topology also is a CSMA CD. That means what? At any point of time, only one machine can transmit. If more than one machine transmit at the same time, then there will be a collision. The same problem repeats. What was the problem in bus topology also is there in the star topology, but the star topology actually came up with a different hardware, which made the connectivity very easy. But setting up the bus topology network with the help of wires connecting to wires was not so easy. It was actually a difficult task, used to be those days. All right. This is some discussion about topologies.